Okay, hey, training plants every day. Jordan School coming at you from the STEM Lab. Kind of kicking it here with the universal field theory and the codex, as it were, the Four Horsemen's Nice Tour Cipher Hypercube. And this is a fun little bit of art, and this is a fun little bit of art, and when you get working with these two things together, applying it into the shop, that's your basic structure. In the shop, you're not looking at it militaristically. You're looking at it more towards the combinations and codes. The code principle can change. You can change the algorithm and the messages you want to change. And breaking that down and looking at an A structure, because or is the great matter of A state, as it's applied in this version. Again, encoded in this guide, you'll find base of A mechanics and the processes used to break down or build anything and everything. To this concept, A refers to the reference forms, frames of reference, A frame of or to motion. And in this guide, we will begin with the concepts of seed, stem, swag, to help understand the other concepts from A mechanics or other models or what have you. Cool little Polish star. Breaking down to the bank of terms. The bank of terms is essentially your alphabetical principles. You're kind of playing it in terms of which of these methods are best going to explain in the frame in which I'm looking for. You might see some basic algebra, some basic trig, some basic psychology, but all basically it's an A mechanical system. I'm breaking them down the same way, but this one applies in better terms to this system. Linguistically, with the alphabet, or how you're playing the floor, dimensionally here. Algebraically, Algebra 2. Introduction. You can see that kind of principle overlaid in a system like this. Some random coding involved in general relativity and special relativity, which are applied in mono and poly cipher systems as you're building them down, and some basic mechanics in terms of geometry in this system to help you explain how it's going to work specifically in said books or concepts. Even though they might be different, they got to apply the same mechanics. Physics follows that rule. And you can break down into more general relativity. Frames per second, essentially, here is no difference from having a sequence of these things to put together, but in terms of the grid in the back, essentially the same deal, played dimensionally different, and with different time scales and systems that still play within the basis of physics to help you distinguish where that particle and momentum of it really are and the entropy of those states. Explains that territory here while you begin to break it down for a STEM problem field theory. In terms of Rhodes conjecture, that's an abruptly long sequence of if the sum of reciprocal of the element of A set A comprised of positive integers diverges, then A contains an abruptly long sequence of numbers with constant differences between terms, and it's reciprocating, maybe to a different RPM given the state, given how much fuel and oxygen really got in there, based of the perfect STEM value of it, really being able to determine that much, down to that much with this much, even if it's like 2 milligrams in an atom, and what therefore would be the combustible of that state. When you look at the physics, you would say that's how I frame that, that's how I analyze it to figure out what that is, and how to do it better, make it that given the frame that it might be in. Bigger, smaller, might make a difference physically. It changes those numbers, and grid states and companies and other models such apply with that model in mind, and it's why Sun Tzu usually works very well determining some of the base functions that, kind of what's strong right now, who's strategically sound, what are their plays, what do they do, when you can't crack the code, When you can't crack the code, do you analyze it from the other side? What are the people doing? Who are the players? I do know some parts. This came from something which analyzed into something else, which could refer to other things, depending on what you do know about those things, or what may not be perceived as direct information in terms of how it's laid out and organized in a direct model could be a very important system. That's what Fermat's and Beal's process here correlates to, in referencing a Ying's-Meals mass gap and a P versus NP problem for many cases, for all cases. Hodge's conjecture is referencing how that dimensional playout can kind of look, how that sequence changes, and how to kind of first build into a set where now it's just starting to work frequently in terms of not just its basic mechanics, but also higher in-depth processes and how they overlay or may connect or relate to that issue, giving to a Brick-and-Dyer conjecture problem, which is mathematics have always been fascinated by the problem of describing all solutions with a whole number x, y, z to an algebraic equation like x2 plus y2 equals z2. Algebra 2 method that is very adaptive and quick in terms of how it may be presented versus its A state. Euclidean gain to complete solution of that equation. But for more complicated equations, which this becomes extremely difficult, i.e. there is no general method for determining when such equations have solutions in whole numbers, but in special cases one can hope to say something when the solutions are the point of an algebraic Abelin value, or Abelin variety. They play like air turbulence equations with a higher entropy state. More frames of mathematically how that positions itself, or how you may present yourself to the horizon of it. It might just be relative there. The Brick and conjecture asserts that the size of that given group of rational points are related to the behavior of any associated zeta functions, and that's applying to this end value function to where you want to apply it, where that symbol near the point s equals 1, that is the first move as much as the last move, all moves can be correlated to that point. Think about your map and strategy. Is not the principles, the particulars. This amazing conjecture asserts that if z equals 1 is equal to 0 point, I applied it like that. Then therefore are an infinite number of rational points, because that would be a irrational number, 0 point. It's not 0. It doesn't apply to a base system. It would apply to more that applies to the base system. Y is the code in this, and all points. The second y. Aristotle's common sense physics. That's a fun one. Really? There's a whole bunch of breakdowns. I gotta do some more. I gotta slip one between Aristotle and physics, and the birth of a new quantum physics, and general command directives. Because then general command directives are any one of those models that you apply them out to be, and that applies to code combinations, ways you can set it up, how you could use it, put it in a computer, don't put a computer, the multiple ways to tame this beast. So you know, when you're in the shop, you know, you're just kind of comprising it, not just of this whole master, you know, play layout. Sometimes it's just little moves on top of little moves, which gets you into the name, the concept, the A, and there's the geometry right behind it. AX equals CZ to the function. I'm going to put this A next to that A because they're both A number I got to calculate to in Algebra 3. Algebra 4. Getting out there. Hey, boss, man. You know, I'm telling you the basic block routine of the day. You know, all right, I already saw it all. I kind of know what I'm going to do with it. I saw the order, and then it's just follow through. Maybe you want to break it down a certain way. That's Algebra 4. You know, you walk up to them, and you're just waiting for the right. And the purpose of all this is because you would have a great little breakdown for it. You would have individual sets. Each of them have individual sets, littler guys that go into a master blueprint plan, and you're given a solution that applies this function. You're playing with all kinds of different electromagnetic spectrums, you know, dealing with a little compass kind of deal here. Got some magnets and electricity systems going into it. You know, you got field ratios. You got how are they square? Are they globular? Are they... Of course, a good old force MA problem. So, that's the universal field theory, and, you know, that's got to be finished out. You know, we're going to knock that one out one of these days, but the principle definitely works and it'll apply. I've done it before with another model that I had, breaking down work principles, great resume base. And again, you know, you're going to do it again. You know, once you get all that laid out, do it again, make it cleaner, fit better, put more into it if you want to make it work better. Refine it down, you know, certain groups, refine down what kind of code you would use, you know, a master one building it for them, or, you know, some high complex one for whatever reason you're going to do. You know, that's nuclear reactors, and catch you on the next one.